Yeah, hello guys. Good afternoon. Yeah, there's a try question on waveguide impedance. Yeah, waveguide frequency. Yeah, so the question is an air-filled rectangular waveguide has inner dimension of 3 centimeters by 2 centimeters. The wave guide impedance of the TE20 mode of propagation in the waveguide at a frequency of 30 gigahertz. Okay, so we write down our data from the question given. Data we know with a rectangular guide. So rectangular, you know the dimension. There will be the dimension A and B. So we know the dimension AB. Okay, let me draw something to help those who to know where I'm coming from. Yeah, something like this. So dimension A and dimension B. So this wave guide, a rectangular wave guide, This B, this A. So this place is neighbor 3 centimeters and 2 centimeters. Okay, and we are also given frequency propagation waveguide frequency to be 30 gigahertz. Yes, then the free space is 377 ohms. So in terms of TA, the equation for impedance TE is equal to the mu O over square root of what 1 minus bracket the cutoff frequency over frequency squared. Yes, so this is our equation, but note when is Tm, the equation is different. This will be the equation for Tm. That will be mu O is it minus no mu O, yes, it will multiply rather 1 minus Fc over F all squared. Yeah, please, if you find this material useful, please like and share, and don't forget to subscribe. Yeah, thank you very much. So in order to find for impedance TA, we need to first find the cutoff frequency. Yeah, and we know the cutoff frequency Fc to bracket 1 over 2 pi mu O O m power over E squared plus n power over A all squared. We know A and B, and from TE20 we know it implies that m is equal to 2 and n is equal to 0. It implies that this one will be equal to 0 sake of it's multiplying this. So since n is equal to 0, we don't need this side because all this side is going to be 0. So in order to make our work simple and easier, we will take this one off and work only with this one, right? Yeah, so fc will be equal to, and this one is equal to, the whole of this place is equal to the speed of light over 2 pi all over 2 pi over a is what? A is 3. 2 pi over 3. But it's in centimeters. It's in centimeters, so it's times 10 raised to the power negative 2, because you are not working in centimeters. You understand? Yes. So note this FC. Let me write it here. FC will be equal to 3 times 10 raised to the power 8. The speed of light is constant. Yeah, it's constant. So this one, no need to do anything else. So pi all over 3 times 10 raised to the power negative 2 all squared. So the square cancel the square root, pi cancel pi. You understand? 2 pi cancel 2 pi. The 2 also cancel 2. So FC will be equal to 3 times 10 raised to the power 8 all over 3 times 10 raised to the power negative 2. So if you calculate, punch on your calculator, you will get 10 gigahertz. So this will be our cutoff frequency. So now let's move back to our main equation that we'll be solving for the TE. So we say TE will be equal to, the LO was given, the relative of free space that was here, it was 377 over the square root of 1 minus cutoff frequency was 10 gigahertz to 30 gigahertz over 2, sorry, over 2. So with this, when we punch this on our calculator and you punch it right, we are going to get approximately, we are going to get something 399.8 ohms, which is approximately let me write this TE, which is approximately 400 ohms. Yeah, so this will be propagation wave impedance. Thank you. If you find this material useful, please like and share. Thank you very much, and please don't forget to subscribe when a new video is posted. You will get a notification. Thank you.